Just to recap, by the end of the previous video, I had convinced you of the fact that if you have g of x being the integral from something up to x of f of t dt, we know that g prime of x will simply be the inside function, which is f of t, so f of x. And further, if we have that h of x is the integral of the other way around, from x up to a of f of t dt, this will mean that h prime of x is the opposite of the inside function, f of x. And as far as I can tell, I feel like this probably covers like 80% of the questions in this vein that are asked on the AP exam. By the way, this all means something, which I may get to in a quick fourth video. But even if it's just for now, suffice to say that we can do this. The majority of examples, or the large majority, are going to fall into cases like these. There is one more level of complexity that I think we should be aware of. It occasionally gets tested, and so we should be aware of it. And if you followed everything up to this point, it shouldn't be too bad. What it really boils down to is, what if the thing here isn't just x? What if it's a little bit more complicated than x? So let's take a look at one of those. So suppose I tell you that f of x is the integral from 5 up to 2x of, some function. I actually kind of liked using, let's use one of those cosine ones again. Let's do the cosine squared of t dt. You may have noticed, by the way, that I always put a t inside here. The thing that's important is whatever letter is here can't be x. And the reason is just that you can't, in some sense, it's not really right to plug in an x if, like, you can't plug in the x for the x that's already there. So we're supposed to use a different variable when we're inside of here. At any rate, in this question, I'd like to know what f prime of x is. And similar to what I've done before, I'm going to go ahead and give you the answer first and then justify that answer. Because the x is on top, the answer we get is going to be positive. It's not going to be the negative opposite thing. But I am going to have to multiply by the derivative of that thing. So in short, the answer I'm going to end up with here for f prime of x is going to be cosine squared of 2x times the derivative of this piece, which is 2. Right? So let me justify why that happens. Just like we've done before, I'm going to start by saying, well, what is f of x? By the way, for the purposes of the homework, if you understand this, great, you're going to be able to do that. I just want to explain where it's going to come from here. I don't know what the antiderivative of cosine squared t is, so I'm going to say that it's question mark of 2x minus question mark of 5. Then, when I take the derivative of this thing, and this is important, if I ask you to take the derivative of this, do you recognize that this will require the chain rule? There is something plugged in to question mark. The derivative of this is going to be sort of, and this is going to be silly notation, question mark prime of 2x times 2 minus, this thing is a constant, so its derivative will be 0. And so to finish this thing out, f prime of x is 2 times, now what is the derivative of question mark? It just goes back to this thing. So it's going to be cosine squared 2x. Right. Let's look at another example of that. So suppose this time I tell you that g of x is equal to, and I'll make this one even more interesting, g of x is the integral from 5x up to x squared of, and I'll actually keep this part fairly nice, of the sine of t dt. Well, in some sense, hopefully we can put this together. When there's an x on top, it's the first thing and it's positive. When there's an x on the bottom, it's the second thing and therefore it's negative. So the derivative of this thing, I'm sort of going to try this out. Let's write the answer all the way at the bottom, indicating that we can, and then we'll show the work that leads to it. the derivative of x squared is 2x, so 2x times the sine of x squared, minus the derivative of 5x is 5 times the sine of 5x. And again, where did that come from? Well, we've done it before. We can say that g of x is question mark of x squared minus question mark of 5x. Then, if I want to take the derivative of this thing, this time neither one of these is a constant, so I'm not going to end up with a 0 down here. Further, both of them have something plugged in, which means both of them require a chain rule. The chain rule on the first one is going to generate 2x times something. On the second one, the chain rule is going to generate 5 times something. So what's the something here in this first one? Well, it's the original integrand sine of x squared, and on the other one, it's the original integrand, the sine of 5x. And note that that's exactly what we said the thing was going to be down here. That's sort of the short of how this whole thing works. If there's a value that's up on top, that's going to be the first thing we write down. If there's a value that's on the bottom, it'll be the second thing we write down. I am going to go through one more example of this. This last example is something that the chances of my testing on is about 1%. I really don't think it's something that's tested on the AP exam, yet it's something that I think bears mentioning. So if you'd like to see this, take a look. If you're done, you're done. I do believe there's going to be a fourth video on this where I use this for one practical problem, so make sure you check that one out so that you're ready for the homework. So this last crazy example, what if I tell you h of x is the integral from, let's say, 2x up to x squared of the sine of t cubed dt. In some sense, this is going to be very similar. The scary thing is how the x squared is going to interact with the t cubed. Let me start by showing you the answer. And if you're interested, you may want to pause the video and try it on your own. But I'm going to start by showing the answer at the bottom, and then I'll show the work that leads to it. So h prime of x, it turns out, is going to be 2x times the sine of x to the 6th minus 2 times the sine of 8x cubed. And if you're looking at that answer, you are probably looking at it saying, like, that can't be right. This is supposed to have something to do with the chain rule. This x to the 6th, the derivative of that should be 6x to the 5th, not 2x. The derivative of this 8x cubed, that's like 24x squared, not 2. What the heck is going on here? Let's show the work in terms of where this comes from, and I think you'll see it. Can we make a statement about what h of x is? Sure we can. We can say, I have no idea what the integral of sine of t cubed is. That's a problem that would take a u substitution because of the t cubed, but there isn't a t squared out front, so we're really out of luck here. We would simply say that this is question mark of what? It's the question mark function with x squared plugged in. So question mark of x squared minus question mark of 2x. Now suppose I want to take the derivative of that. When I take the derivative, note, this isn't x to the 6th yet. It's x squared that got plugged in. So the chain rule simply says the derivative of x squared is 2x times, question mark prime of x squared minus 2 times, oops, I forgot the closing parenthesis, that was question mark of x squared, minus 2 times question mark prime of 2x. And so now, sort of our final step then is to say, okay, well great, I know I've got this 2x that's waiting here. What is question mark prime? Question mark prime is this function with x squared plugged into the t. So this is going to be sine of not t cubed, but x squared cubed minus 2 times the sine of not t, not t cubed, but 2x cubed. And then in the final step, you can see how that just simplifies to the x to the 6th. This just simplifies to the 8x cubed. Like I said, it's a very complicated example. I feel like this might show up as one question, a hard question on the AP exam. I don't foresee them doing something like this in like a free response question as part of an extended thing. If it's a part of a word problem, which is what the AP exam does a lot of, it's going to be some of the easier problems that we're talked about in this video. I am now going to make that fourth video about one practical application of this problem. So we'll take a look at that next, and then we'll be done for the night.